Happiness cannot be behind sorrow. It is your choice to make a better tomorrow. Enjoy this beautiful day with a lovely smile. Good evening to one and all present here. On behalf of PG and Research Department of Mathematics, DG Vaishnav College, I welcome all the PG students and CSIR aspirants. Pray, then let it go. Don't try and manipulate or force the outcome. Just trust God to open the right doors at the right time. Now, Tamatar Vatu followed by college prayer.
சீராரும் வதனமென திகழ்வரத கண்டமிழே எக்கணமும் அதிசிறந்த திராவிடனல் திருநாடும் தக்க சிறு பிறை முதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம் மிகுந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
सत्यव्रतं सत्यपरं त्रिसत्यं सत्यस्य योनिं निहितं च सत्ये सत्यस्य सत्यं ऋतसत्यनेत्रं सत्यात्मकं त्वां शरणं प्रपन्नाः वाणी गुणानुकथने श्रवणो कथायां हस्तौ च कर्मसु मनस्तव पादयोर्नः स्मृत्यां शिरस्तव निवास जगत्प्रणामे दृष्टिः सतां दर्शनेस्तु भवत्तनूनाम् नमो भगवते तस्मै कृष्णायाद्भुतकर्मणे रूपनामविभेदेन जगत्क्रीडति यो यतः ॐ शान्ति शान्ति शान्तिः.
This is C for workshop, says crack conquer CSIR net, which will make the CSIR aspirants to go to the next level. Now, I would like to invite Mr. P. Thirumal, Assistant Professor, PG and Research Department of Mathematics, DG Vaishnav College, to introduce our resource person.
Good evening to all. I am very happy to introduce our resource person, Dr. C. Ilango, Associate Professor in Mathematical Sciences, Cardamom Planters Association College, Bodinaikanur. Sir did his BSc Mathematics in Scott Christian College, Nagarkoil, Madurai Kamarajar University during the year 1977 to 80. MSc Mathematics in ANJA College, Sivagasi, Madurai Kamarajar University during the year 1980 to 82. He did his MPhil and PhD in School of Mathematical Sciences, Madurai Kamaraj University, Madurai. He is a co-author of a book, Business Mathematics, published by Parani Paramount Publications, and Preparation Manual for UGC NET SLET Examinations, Brain Academy Publications, Madurai. Sir has 18 years experience in teaching mathematics and theoretical computer science at UG and PG level. 4 years experience in computer applications and algorithm design. 7 years research experience in operations research, inventory control systems. Presently working on a project in supply chain management system funded by CSIR New Delhi. With this brief introduction, I welcome you, sir. Now I hand over the session to you, sir.
Hare Krishna. My dear participants of this program, first of all, I thank the VAISHNAV College management, the faculty members, and the organizers of the program for giving me the opportunity to deliver a lecture, that is focused lecture on CSIR Mathematical Sciences NET examination. The problem is how to crack the examination, how to chase the examination, how to conquer in the competition. That is more important. Usually, when you take a subject and learning a subject and understanding the basics of things and doing problems and research is something different. That you can understand the definitions, theorems, corollaries, and consequence, remarks, counterexamples, and finally you solve some problems and you get a knowledge of that. But this competitive examination, CSIR, nowadays become highly complicated because that examination has been started it has been conducted for the past 20 years. Year by year, the questions become more complicated. And most of the questions are not direct questions. And there are 6 levels of questioning. One is knowledge level, another one is application level, another one is analysis level, and another one is the interlocking, that is combining 2 ideas. And for example, I can tell there is a problem. Algebra is one area, that is classical algebra, and probability theory is another area, another topic. And nowadays, the questions are asked in the area of synthesis method. Analysis, next one is synthesis. What do you mean by synthesis? The questions are asked by combining 2 ideas. An algebraic idea is combined with probability and in the examination. So, the year by year, the question taken by the questions prepared by the examiners for examination itself is very complicated unless the examiner has a concrete idea on algebra and also on probability theory. They can set a question. For example, I can give a very simple example that suppose you are able to solve an equation, third degree equation, x cube minus 1 equal to 0, and collect the solution, put it on the back. Okay. Solve the equation x cube minus 1 equal to 0. You get some solutions and take the solution, write them on the small board. Okay.
Sir,
and then put it on the back.
Sir, sorry, sir, disturbing you.
Yes.
Sir, your screen not shared, sir. Your screen, sir.
Screen.
Yes.
Screen is not.
No, sir. Your PPT or
PPT.
Yes, sir.
Okay, I'm not giving PPT. Okay, I'll give the PPT. Okay.
Okay, sir. Okay, sir.
Okay, that's 2 minutes ago.
Okay,
Then
okay, sir. Okay.
put the solution on the card and take one of the card. What is the probability that the solution is a complex number? This type of question will be asked. This is very simple. When you solve a question, x cube minus 1 equal to 0, there are 3 solutions. One is a real solution and the other 2 are complex solutions. Therefore, 3 solutions are there. You are selecting one. What is the probability of getting a complex solution? That is 2 by 3. So, this type of problem will be asked. Okay. For solving statistics and probability, so I am interested in applied probability theory. My area is operational research and inventory control theory and queuing systems, and how you can solve the problems in statistics. First of all, you please go through the CSIR examination papers. Okay, and that will be very much useful to you. Now I will like to give you short notes on probability theory. So if you want to do any course, if you want to understand statistics, the root is the probability theory. So I would like to share my slide. First, you please go through it. Are you able to see the screen? Okay, now let us come to the basic concepts of probability. That is very much important for solving probability problems. First of all, probability, what do you mean by probability? Probability is nothing but the chance of occurrence of an event. The measure, it is a measure of chance of occurrence of an event. How and whether an event can occur or not, what is the probability of occurrence? How it can be calculated? So, the history of probability is concerned, it starts from classical probability. It is called a priori probability. People should understand the difference between these four important concepts, and then it changed into frequency-based probability, and that is called post priori probability. And then third one is very complicated, it is subjective probability, and finally we arrived at axiomatic probability. The axiomatic probability has been done by, at present, most of the CSIR examination, most of the courses in India, throughout the world, we are doing courses on axiomatic probability. But not directly we are come to axiomatic probability. What do you mean by classical probability? That we have to understand first. That is called a priori probability. Why it is called a priori probability? That means without doing any experiment. It is a mathematical model. Without doing any experiment, we can do probability. We can compute the things. Okay, there is no need of doing experiment. You take a coin, throw it. What is the probability of getting head? Very easy, because we are having only two sides, head or tail. It is 1/2. Without doing, tossing a coin, without doing any experiment, you can do it. But provided there are some conditions are there. It should be an unbiased coin, and there is no air resistance. All these conditions, subject to these conditions. Okay, if you are doing the experiment, without doing experiment, we can do things. Okay, what about posteriori probability? You have to do the experiments again and again. 100 times you do the experiment, and after that you are getting only 70 times a particular event. Then what is your probability? 70 by 100, that is 0.7. You are experimenting a probability by doing an experiment repeatedly for 1,000 times, but you are getting a particular event. You are fixing an event that is not desired event, and that desired event occurs for only 600 times. What is the probability? Out of 1,000 times, you are getting only 600 times that particular event. Okay, then what is your probability? 0.6. And these things can be done only after doing, that is called posteriori probability. After doing the experiment, only you can do. This was the second stage of things. And what do you mean by subjective probability? I think most of you have not heard of this. It's a very complicated one. I can give if you take a probability model that will solve any kind of problems. So it is fortunate enough, I would like to give a set of question paper. I'm going to give you a set of questions and answers for a book. And the book was written by Ken Chijins from Switzerland. And that was already given to, I had sent it to Professor Venkataraman. He will share it with you. And please see that most of the questions, they are real life questions. In a car parking area, a car is entering every 1 hour time. And the police is entering into the yard. If there is a wrong parking, he will be immediately fined. Then at randomly, both events are happening. Entering a car and entering a police. And at what time, suppose a car is entering at 11 o'clock, what is the problem that he is got by the police? So these kind of original problems are solved, and these kind of questions are asked in the examinations. Okay, and this can be done only by we will accept probability as a right tool to solve the problem, to tackle the probability problems. Only when it is able to solve all real life problems acquired in reality. Okay, now let us come to the subjective probability. One can ask a question: how much your wife loves you? It's a very complicated question. What is the probability? What is the probability that your wife will love you? This one cannot do. What is the sample space? What is your desirable event? You cannot compute all these things. These are subject. Now I can ask another question. One man asked a question, that is, what is the probability that in 2023 the World War III will happen? Are you able to understand my question? What is the probability that in 2023 the World War will occur? Third World War. Nobody can answer. Are you able to answer? If you are able to answer, these are all subjective probability. Okay, the problems are three kinds. Classical probability. In most of the classical probability, they are equally likely events. That's very important. In classical probability, all the events are, for example, you are throwing a die. What is the probability of getting 1, 2, 3, all are equally likely events. And frequency based, it is not so. But subjective, even your sample space cannot be defined clearly. Then how can you find a probability? So that is why to overcome all these difficulties, that axiomatic probability has been defined. Now let us come to the slide. Okay, when you are doing a probability, first you have to do a random experiment. What do you mean by random experiment? A scientific experiment conducted, it is given as conducted under specific conditions whose outcomes are known but not predicted earlier. That is called random experiment. Okay. What is an example? Tossing an unbiased coin. You know, the condition there without no air pressure. The condition is a random experiment. We know there are two outcomes, head and tail, but you are unable to predict it whether head will come or so that is. Now let us come to sample space. But slowly move. Sample space denoted by omega is a collection of the totality of all possible outcomes. It is aggregation of all possible outcomes. This is very important. In some of the cases, your sample space may be infinite. In some case, the sample space may be finite. But here, the problem is most of your protein problems hold short. What is your sample space? When you are tossing a coin, it is head and tail. It's very simple, 2 elements. Throwing a coin, only 6 elements. Throwing 2 dice, it is 36. Throwing 2 coins, it is 4. So 2 into 2, 4. So these are all very simple. But in reality, It is not so. You take a bulb, you put a bulb or electronic gadget into action. At what time it will expire? Nobody knows. The probability of expire is random. At what time it may turn off at 0 time or 1.1 minute or 7 point. It may go for 1 hour or 200 hours or it may go for 1 year. Nobody can. So that is, what is your sample space here? This is very complicated. It is 0 to infinite. Your sample space is a continuous space. It is R plus. It goes to 0 to infinite. So in that case, what can you? It is to find the probability is very complicated. That is why you go for exponential distribution. When you take either you go for uniform distribution or exponential distribution, that only deal with these kind of problems. And the lifetime of electric bulb is always an exponential distribution because it has a memory plus property. Okay, that we'll do in the next course. And in detail, sample space is very complex. Another one important things I have to tell you. The sample space, people actually, the next one is the random experiment, sample space, event space, and probability. These 4 things are very important. If you are able to, if you want to solve a problem is given in the examination. If you want to solve it, first you should understand what is the random experiment. The second one is what is the sample space you have to fix. At least you must understand the sample space. Then event space. What do you mean by event space? What is the desired event? That is a subset of sample space. That is a subset of sample space. This is where you should be very careful. My question. And then you can calculate the probability. What is the probability? That computation is very easy. The n of s divided by n of your event space, or n of a divided by n of s, n of omega. Omega is the sample space, number of elements in omega, number of elements in a, and you take the ratio, and that will give you the probability. Now the problem is, be careful. Event set is a subset of sample space. Now the question is every subset is an event. Every subset of a sample space an event? It's a very complicated question. Is every subset of an event space is a sample space? Every subset of a sample space is an event or not? But people think that event is nothing but a subset of sample space. It is not so. It is wrong. When the sample space is finite, you can say that all subsets are events. If the sample space is infinite, just like our infinite space, lifetime of a bulb, that every subset is not an event. Then what kind of sets? So you have to collect a class of sets. That will be even space. I can call it as an even space. What kind of set I can collect? That is very simple. You have a collection of subsets of a sample space which satisfies 3 conditions. The first condition is phi empty set and the whole set omega should be a member of that class. I call it as a script C class. And second one is if A is an element of that class even space, then A complement is also there. And another one is if A1, A2, A are a subset of a sample space omega, then union of A1, A2, A also belongs to that. Then only we can say that this is called, and this class of set is called sigma algebra. This union means it is countable union. A1, A2, A up to infinite. Okay, it is countable. The countable union of subsets of sample space is again a sample space. Then that will show you later. Okay, then it is therefore this even space, even every subset of sample space is not an even. If the even set satisfies this condition, then only it is a even. For that even only we can compute probability. For that you have to get the set function. Okay, we have to define a function that is called a set function, and for So throughout probability, you are doing three things. First, you should understand what is set union, set intersection, all this set logic. And next one is a function. Function is not a point function. You have to do a set function. The set function concept is clear, then you have to define as probability space. How you can define a sample? For example, see, an event, what do you mean by event? Event is a subset of a sample space, but not everything. The class of events associated with the given experiment is defined to be an event space. It is a class of events. And that is called the sigma algebra. That is why I put here it is not ordinary set, sigma algebra of sets. Or simply you can call it as algebra. What is the difference between sigma algebra and algebra? Sigma algebra means countable union should be there. Here it is finite union is there. Okay. Then if two properties are there. Now let us take a event set. And this is a sample space. When you take three different coins, 1 rupee coin, 2 rupee coin, and 5 rupees coin, and you toss it. Sorry, it is three different coins. It's not two, it is three different coins. Change it. What are the head, tail, and you will get how many? And 8 different sets you can get. From that, you have to find, first suppose I need only first two are 1 rupee and 2 rupee coin at head and the other one is tail. And what is the possibility? That is this one. This is 1 by 8. All these can be computed very easy. Now let us come to the, and what do you mean by even space? This has the following property. The whole omega belongs to B. A belongs to B, implies A complement belongs to beta. Because beta is a collection of subsets of sample space. And if A1 and A2 belongs to B, A1 union A2 belongs. In general, if it is a sigma algebra also, if the A1, A2, AN, generalize A1, A2, AN, etc. belongs to B, and the countable union belongs to B, and then it is called. Okay, and these three properties are given. But here also, omega is the whole set is in B, and also empty set is also there. Why empty? But I have not put empty. Why? Because this property will imply this. If A and A bar belongs to this, A belongs to B means A complement. If omega belongs to beta, B, automatically omega complement, that is pi is also there. Therefore, there is no need of that. Okay, so with this fundamentals, and now let us go to set. I have defined only set concept. Now let us go to set function. When you define a set function, that should also satisfy some three conditions, and that will become a probabilistic model. Okay, now let us come to the next slide. Okay, how can you define the probability set function? As I told you, let C denote, there I put B, script B, this is script C, denote the sample space. What is the collection of events? The collection of events means not all the subsets. You have to take a sigma, but let beta be a collection of subsets of C, D. This is what B is a collection of subsets of C. And C, here C is nothing but a sample space. Instead of omega, we put C. C is nothing but a sample space. And let B be the collection of subsets of B satisfying these three conditions. Phi belongs to B. So in my first slide, I show you omega belongs to B. Here, phi belongs to B. Phi belongs to B, automatically C also belongs to B. Because what is the pi complement? It is C. And C belongs to B means C complement also belongs to B. This is ordinary C set. C complement belongs to B. And if a sequence of set C1, C2, Cn is in B, then union of Ca also belongs to B. Now we can see it is C is closed under countable unions. And it is closed under countable union and complementary, then it's so. and all these things. Now there is another question. If A1, C1, C2 are in B, can you take intersection is also there? The intersection of the sets is also there. Because union of CA, what is the complement of this? That is intersection of CA complement. According to our second rule, CA complement is also there. When CA is there, CA complement is there. Their intersection is also there. So the problem is over. So, and then if all these things are defined, then automatically we come to the probability set function. If this satisfies this condition, let C be a sample space and B be the sigma field on C and B be a real value, we have to define a real value function P. That is your probability function. This is not our ordinary function like F. F be a function from X to Y such that it is continuous. All these are point-wise. F of X goes to Y. It takes X to Y, one point to another point. This is called ordinary mapping. Here it is not so. That is why it is something complicated function. In function analysis or in real analysis or complex analysis, we dealt with two kinds of functions. Function F from R to R, and real to real, or complex to complex, or complex to real. All these are different. But here we are taking a function P from the class of set B, beta, script B, class of set script B to 0, 1. That is very important. To not the whole real line, to 0, 1. That is not mentioned here. P is a real value function defined on B. That means it is not probability, it is not dependent from 0 to 1. That is into function. And P is a probability set function, and the condition is probability of C is greater than or equal to 0, and probability of the whole script is, this is script C, is equal to 1. And if Cn is a sequence in B, at Cn intersection B is equal to Mt, when M is all disjoint sets,
Sir?
probability of union of N equal to Cn is equal to this. With
Sir?
this property, and this is
Sorry,
called
sir.
boundary additive property.
Sir?
Hello?
Sir, your screen is closed, sir. PPT, sir.
PPT is not closed.
Yes, not visible, sir. For us, sir.
It is not visible.
Not visible, sir. PPT not visible, sir.
Okay.
You have to share again.
Well, I have to share it again.
Yes, sir.
Oh. Okay. Yeah. This one.
Okay, sir. Now visible.
Now it is. I'm very sorry. So I will like to. So you take a probability set function. What is a probability set function? Sigma field. B is a collection of subsets of C. Okay, as I already script B is a collection of subsets of C. I already told that every subset is not an event. So you take a collection of subsets of B satisfying these three conditions. Phi belongs to B. Or you can say it is script C belongs to B. Okay, any one of them you can take. And if C belongs to B and C complement also belongs to B, C means C is a subset of script C. It is not script, the whole sample space. Your sample space is script C. There is a difference between C and this C. And its complement is there. If a sequence of elements C1, C2 is in B, then union is, if this is satisfied, this is called sigma field. Why it is sigma field? Because it is a countable union of sets. You take a union of sets. If it is a countable union of sets belongs to B, then intersection is also there. Can you say that the intersection is also there? Intersection of C is also there, because what is by our De Morgan's law, intersection CA is what is this? This is nothing but complement of. So intersection of CA is equal to union of CA complement. But each CA complement is in B, therefore it is there. Okay, and this is for even space. And now you have to define the probability set function. Let C be a sample space and script be the sigma field in C, and let P be a real valued function defined on B. What do you mean by real valued function? Usually, you take a probability, that function, usually we are defining with the function F, ordinary function from R to R, or R to complex. These are all set functions. There you can think of continuity. Here we cannot think about continuity because it is not a point function. So point function only, what is meant by continuity? A function can be a continuous function, it can be drawn. Its graph can be drawn without taking the pencil. But here, that concept is not allowed here. P is a set valued function. It takes one set to another number. As a set can be matched to a number from 0 to 1. What is the probability of an event A? That lies between 0 and 1. So it is a set function. It takes, depend from collection of the sigma field beta to 0, 1. And P is a probability set function. This is called not probability function, probability set function. And probability of C is always positive. And probability of whole space is equal to 1. Sample space is equal to 1. And if Cn is a sequence of sets in B and disjoint, these sets are disjoint, then probability of union n equal to infinity, Cn is equal to sigma I equal to 1. What is the meaning of this? It is countably additive. Why we need this property? This is equivalent to our continuous property. Unless a function is continuous, distribution function, it is f of x, its probability density function is continuous, you can find a total probability. Similarly, this is countably additive property. Union of n equal to disjoint union of events is equal to sum of events. If countably additive property, then only you can define. Now we have set the platform. How to compute probability? Probability is, as I told, that is axiomatic probability is clearly defined. You take a sigma sample space. From the sample space, you collect a collection of sets that are called, that is called a sigma field or sigma algebra, which contains a collection of sets satisfying the three conditions that I told earlier. Now we can define for that class of sets B, you define a set function P from B to 0, 1, satisfying these three conditions. Now our problem is over. It will do whole thing. You take any subset of, any event set of a sample space, you can find a probability very easily. The probability function is, that is n of event. Okay, now let us come to, now you see that here, for each event E, what is probability of C? 1 minus probability of C complement. This we can, because our base is over, base things is clear, we can do all the problems. What is the probability that null set? It is 0. That we can prove. All these things can be proved. What is the probability of, if C1 is a subset of C2, then we can say that probability of C1 is less than or equal to probability of C2. All these things we can compute very easily. And probability of C, you take any event, probability always lies between 0 and 1. And all these things. What is probability of union? It is additive property. You take any two subsets, events. Here, I would like to remember one thing, this C1 and C2 are events, mean this belongs to that sigma algebra, not a subset of C. Not all subsets of C1 and C2 you cannot find this probability. But people, unfortunately, our mathematics people that understand mathematics probability in a different way. That is why probability, they are afraid of probability. That is very important. This C1 and C2 are events in C, means they are subsets of sigma algebra. They are the members of sigma algebra, not ordinary subset of C. If you take C1 and C2 are ordinary subsets of C, this condition, this relation does not come. Probability of C1 union C2 is equal to probability of C1 plus C2 is equal to this relation. So you should be very careful. All these things comes under the basic thing that C1 and C2 are events, means they are not ordinary subsets of C. They are members of a sigma algebra, What do you mean by sigma alpha? It is a collection of subsets of script C which satisfy the three conditions. Okay. Now let us come to the probability. And also these probability functions satisfy these three conditions. Probability of empty set is equal to 0. And probability of whole set is script C is equal to 1. And that is union of. If P1, P2, Pn are disjoint, C1, C2, Cn are disjoint subsets, and probability of union of n equal to 1 to infinity Pn is equal to that. I told that, and that is countable additive. If all these three conditions are, then only. Okay, now another important problem is inclusion exclusion problem. What do you mean by this? Probability of C1 union C2 C3 is nothing but you include all the probabilities. Why this? Now let us look at this. Probability of C1 union C2 means first you find the probability of C1. Find the probability of C2. But C1 and C2 may have intersection. And in that intersection, there is a repetition. That is, intersection part is counted 2 times. So you have to remove 1 time for that this probability. This is nothing but counting. Inclusion and exclusion. These two are included. Probability of C1 and C2 are included, and C1 and intersection is excluded. That is why minus is there. There, same inclusion exclusion is used for 3 sets. You sum all the probabilities. Now subtract these intersections because these are counted twice. When you are removing this, you are automatically removing this also, but you have to add it. For that, you have to include it. That's logic. It's very simple. You cannot memorize this formula. So you have to find the probability of C1 union C2 union C3 means first you have to add all the probabilities C1, C2 and C3, 3 events. Then when you are counting these units, because this is nothing but a counting, what is probability of C1? That is number of elements in C1 divided by number of elements in your sample space, script C. And these intersections are counted here twice. For that you have to remove it. So you add all these things and remove it. That is P2 is removed. Then when you are removing this, you have done a mistake. What is your mistake? You have removed this also. The whole intersection. So you have to find the right probability. You have to include it again. That is P3. So for P1 minus P2. So you put this for n k sets. C1, C2, P1 minus P2, P3. And last one is minus 1 for k plus 1 P4. Okay. And all these things you might have studied very well. And now let us take one problem. Let the probability of a set function assign a probability of 1 by 36 to each of the 36 points in C. C is a sample space. Okay. You look at this. This script C is a sample space. It contains 36 points. Usually 36 points means you are taking 2 dice and throw it. How many sample points are there? 36. And that is the dice are paired. And C1 is equal to, I am taking C1 is equal to 1, 1. Here you should remember one thing, all the subsets, because it is only 36 points, it is a finite set. All subsets are evens. Why? If you take all the subsets only, all the 3 conditions should be satisfied. Empty set should be there, and C is there, C complement should be there. That is very important. Suppose you miss some of the sets, that property will not hold. That is why you take C1, 1, 1, 2, 1, 3, 1, 4, 1. So all the second part it will get 1. Other 1, 1, 2, 3, 5. And C2 is 1, 2, 2, 3 this. Then what is P of C1? There are 5 elements, 5 by 36. These computations are very easy. And similarly, and P of C1 union C2, you add these two and subtract C1. What is C1 intersection C2? 0. It is empty. Therefore, you need not remove the things, the problems. And similarly, 2 coins are tossed. And all these problems these are all elementary problems. Now I am going to concentrate on very complicated problem that is given in the material that you feel. All these things are there. Probability, counting rule. Now let us come to the binomial expansion. This is very important. Now, what do you mean by binomial expansion? People think that NCK. But usually we say that NCK is n factorial by k factorial n minus k. And out of n object, you are selecting k things. Okay. And that is called n factorial by k factorial and n minus k factorial. And how this can be calculated? And this is nothing but by, if you take a plus b power n, it is a plus b, a plus b, a plus b. And this, how many times you are taking a? So, if you take only one a and all the others are b, so b times a only one time occurs and all the others will come how many times? N minus 1 times. So, a power n minus 1 into b, all the b is taken n minus 1, so b power n minus 1 into a power 1. This is one. Suppose you take two a's and all the others are b, product. You take a product of a into a and all the others are b. Other terms, you are taking b, selecting b. That is a square into b power n minus 2. Similarly, you take in general ak and b power n minus k. And now the problem is, how many times you take k success? You are taking a, how many times? K times. How many different ways k can be arranged? Out of n objects, you have to take k objects. What is your object a? How it can become taken? NCK ways. So NCK into a power k into n, that is very a plus b. So the combinatorics is very important. Why we are studying permutation, computation, all these things in probability, to do probability problems, permutation and combinations are very important. Okay, that if there is a board, I can explain you what is permutation. What do you mean by permutation? NPR. So I don't want to, so it is not in the slide. I would like to explain what is, before understanding the combination, first you should understand what is permutation. What do you mean by permutation? Permutation of n objects, taking r at a time. It is NPR. The value is n into n minus 1, etc., n minus r minus 1. How you got this formula? So, in most of the cases, our students are memorizing the formulas. That is NPR is equal to n into n minus r minus 1. So, you take odd terms and you starting from n and subtract 1 at a time, 1, n minus 1, n minus 1, and finally n minus r minus 1. That will not work. You please tell me how you got NPR. This is very simple. I can explain. That is not given here. Permutation is not. Okay, this is here. Okay. NPK, n into n minus 1. That is, this is actually NPK. Actually, there are, in a bench, in a class, there are 10 students, but there are only 4 places. In how many different ways this can be arranged? These 10 students can be arranged in 4 places. You put the 4 places. Now let us look at this is without repetition. Okay, therefore, you can take the first place. First place can be filled in how many ways? N ways. First place can be filled in 10 ways because we are having 10 students. Your first place can be filled. Now come to the second place. It can be filled in 9 ways. Already one boy arranged. Okay, 9. Next is 8 ways, 7 ways, and altogether 4. 9 into 10 into 9 into 8 into 7. So last 4th place can be filled in 7 ways. You multiply all these things, you get. Why you are multiplying? Why don't you add? That question is there. So you should ask questions. Then only you can understand what is permutation, and it cannot be added because there is a theorem that is called fundamental theorem of counting. It says that if an event can be performed in m ways, another event b can be performed in n ways, altogether both the events can be performed in m into n ways multiplied. Why you multiply? Because I can give a very simple example. That is, you take Madurai. from Madurai to Chennai, there are two routes. If you want to reach from Madurai to Chennai, there are two routes. From Chennai to Delhi, there are three different routes. A person starting from Madurai can reach Delhi in how many different ways? It is 6 ways, because from Madurai to Chennai, there are two routes. Okay, suppose a person starts the first, he chooses the first route, remaining how many routes are there? 3 ways. Okay, instead of choosing that route, he may have chosen the next route. There are how many choices? 3. 3 plus 3, that is 6. Therefore, multiplication is there. That is why this multiplication is done. N into first place can be filled in n ways, second place n minus 1, and the kth place filled in n minus k minus 1. This I can write it because n minus k minus 1, because n minus k and up to 2, and it become n factorial. This is n minus k factorial. That is why this is permutation. Now let us come to combination. Combination, here we are giving importance to place. Permutation is concerned, we are giving importance to place. Each place is important, but combination is not like that. Combination is the count in which, that is not giving importance to place. We are selecting a committee consisting of k members from n. Now I can give a very simple example. Suppose there are 20 cricket players, 20 students in a class. They know cricket, but I need a team which consisting of only 11 members. 20 players are there, only 11. In how many different ways they can be selected? That is 20C11. That is this. N is 20, K is 11. Okay, and that can be done by how it can be done. This formula, this is equal to n factorial by k factorial. Actually, NCK is equal to, the real formula is NPK divided by k factorial. You look at this, n factorial by n minus k here. That is our PNK. Okay, what is this? Actually, NCK is equal to NPK divided by k factorial. And you cross multiply it. So NPK is NCR, NPR. This is NPK, permutation. Number of permutation of k of n objects taking k at a time is equal to k factorial into NCK. How we got this answer? That is very important. From that only this formula you derived. That is, I would like to explain this again. Suppose, now let us come to another important question. What is the value of NPN? What is how many? Suppose you want to arrange n elements out of n elements. N places, n objects are there. You have to arrange them. What is P, n, P, n? It is n minus 1, n minus k, n minus n minus 1. So it is 1. So it is n factorial. So NPN is equal to n factorial. Okay. Now let us come to this point. This is how you got this answer. This is very simple. That is, there to find a counting, there are 2 ways. If you want to permute, there is a bench which consisting of k places. You see what is the permutation? K places, and n objects are there. You arrange them first in n ways, second in n minus 1. You are direct. Instead of doing this, there is another way. First, you select a committee consisting of k members. Committee consisting of k members, their place is not important. So, in a cricket team, there are 20 players, 11 players. You need not take a who is sitting first, second, that is not a question. Only k members I have to select. Who is sitting where, that is not important. The place is not important. That is why this count is always less than that count. Okay. Permutation count, the combination count is always less than permutation count. Okay, why? And this is not giving more importance to place. Okay, instead of filling the places individually, you select a committee consisting of k members. Okay, and you put the k members in the k places. You remember, it is very important. You are having k members. How many committees you can select? NCK committees. You put the NCK committees and you take one committee. It consists of k members. Put them in k places. Arrange them in how many ways? K factorial ways. You can arrange them in k that is this k factorial ways. Remove the committee. You select another committee. consisting of k elements, arrange them in k places. How many ways? K factorial. One by one you do, how many ways it can be arranged? K factorial into NCK, that is equal to your. Therefore, this is a relation. If you want to study really, if you want to do the counting is more important than algebra. Okay, more complicated than algebra. People think that algebra is GOVERDHAN, but counting techniques is very important, and that is very much necessary for probability theory. Otherwise, you cannot compute the probabilities. If you want to have a clear idea on these counting principles, there are 4 different kinds of counting: permutation, combination, multinomial counting, and repeated counting. There are 4 kinds of counting. But if you want to have a strong idea on this, you please refer to the book written by Kaile Chand. That is Elements of Probability Theory and Stochastic Process by Kaile Chand and some other author. You please go to internet and it is available free. You read the first 2 chapters, then you can understand your permutation and combination. Okay, I have taken much of time on this because why I have taken all this binomial expansion. This binomial theorem, there is a distribution called binomial distribution, and we have to solve so many problems using binomial distribution and how the binomial distribution works. That is why I have taken this a plus b power n. The expansion has n products, and these n products can be computed like this: NCK element. Set A can be taken k times. In how many different ways? NCK ways. And simultaneously, when A takes k times, B can be taken n minus k tuples. Okay. I think I call these as traces. So how many traces are there? N traces. From the n traces, A had taken from k traces, and B can be taken from remaining n minus k traces. And product, you take the product and then sum them. That is where. Okay. So all these fundamental things I have almost done. Now let us come to what is probability of an even C, the number of points in C divided by K. That I call it as f of x. That is f of x is equal to 1 by K. And this is for a particular, the problem is because each can assign a probability 1 by K. So it is equally likely event, and f of x equal to 1 by K. I can call it as sigma ordinary die problem. It is very easy. Okay. And then all these things are increasing events and other things are. So with this I have taken this portion from the book called Mathematical Statistics by Hawk and Gray. You please try to solve these problems. I think this is in page number 34. As you are all aspirants of CSIR net examination, please try to solve at least 50% of these problems. Then automatically your ability will increase and you can solve the problems given in the net examinations. Okay. Usually, in the CSIR exam is concerned, questions are asked from, it's a very complicated area, that is correlation. When there are 2 random variables x, y, how they are related. Correlation, how to find correlation coefficient, regression coefficient. For a simple problem is simple data is given and find the correlation coefficient. It is very easy. Another area they will ask from estimation, that will see in the due course. Okay, estimation theory for a uniform distribution, and theta is a parameter. How can you estimate the parameter theta exactly with the probability of 0.5? With the probability of confidence is 0.97 or 95, 0.95. All these type of questions is asked, and all these things you take sampling theory or hypothesis. What do you mean by hypothesis testing? Hypothesis is nothing but a probabilistic statement. So unless you have a strong footing on how probability is calculated, and probability problems are solved in a lucid manner, then you can go for hypothesis and hypothesis testing and probable error. All these things come under probability. So we cannot directly jump into the hypothesis testing and inferential statistics. All these inferential statistics become very easy when you have a strong footing on probability theory. Okay, so with this I conclude my lecture, first lecture, and let us, this exam, I gave this question, probability exam questions with the solutions by thinking in the, I had sent this question and answers to the program director, Mr. Venkataraman, and you please get a copy of this and try to solve these problems. If there is any doubt, please ask me. Yeah? Then we can discuss in the next class. Okay, with this I conclude my talk. Thank you. Thank you very much.
Thank you, sir.
Thank you. So, question? Do you have any questions? I'm sorry. If there is any question, people can ask.
I think no any questions, sir, till now.
Okay. Okay, thank you. We can see you in the next class tomorrow.
Thank you so much. We wish to express our gratitude to our resource person for being with us on this event. Your explanation is very useful for all of us, sir. Thank you so much, sir. I would like to thank Professor R. Venkatramanan, Head PG and Research Department of Mathematics, for organizing this C4 workshop. Our next C4 session will be held on tomorrow at 11 a.m. Thank you.